Okay, in this section, the last section of curve sketching, we're going to look at a couple special cases. So the first thing it asked me to do is use a graphing calculator to graph the function. Use the graph to determine whether it is possible for the graph of the function to cross the horizontal asymptote. So let's just start with that. I've actually already have in my graphing calculator the graph, and this is what it looks like. So you guys can see that there is a horizontal asymptote right here, and let's go ahead and see what value that is. So it's getting closer and closer to 3 on either side. So we just now have answered that question. Can it cross over that horizontal asymptote? The answer is yes. So can it cross over the horizontal asymptote? Yes, it can. Do you think it's possible for a graph to cross over its vertical asymptote? The answer to this question is no. Now, the reason for that is we're talking about two different things. Horizontal asymptotes talk about the limit as x approaches infinity and the limit as x approaches negative infinity. It never says that it's undefined at that certain y value. It just says that it's getting closer and closer to it as it approaches infinity and closer to it as it approaches negative infinity. On the other hand, a vertical asymptote is telling me where the bottom cannot be 0, where it does not exist. So those x values actually do not exist. So reason being is because vertical asymptotes denote where x does not exist. So vertical asymptotes denote where x does not exist, where horizontal asymptotes just say that it's getting closer and closer to that value of y as it gets further and further out to infinity. It doesn't ever talk about something that does not exist. Okay. Moving on, then I think I've answered all these questions. We're going to look at this one. I am not going to graph this on a graphing calculator because we've talked about this many times this year already. And it says use a graphing calculator to graph the function and explain why there's no vertical asymptote. Well, there looks to be a vertical asymptote at x equals 1. But when you guys have learned, or what we've learned this year, is if we were to factor this top and look at it in comparison to the bottom, we notice that we could actually cancel these out. What that does is it creates a hole. Creates a hole, not an asymptote. So x does not exist on this function at 1. So x does not exist at 1. It's not part of the domain. The domain is all reals except x cannot be 1. But it doesn't create a vertical asymptote because you are able to cancel with the top. When this occurs, we call that a removable discontinuity. We've talked about this earlier this year. As far as I have one more slide I want to talk about with you, but I will do that in the next video.